In this mini lesson, you are going to learn a way to organize all of the possible outcomes if you are completing two or more what we call independent events. So an event is something like the roll of a die, the flip of a coin, the spin of a spinner, pulling a card, all those sorts of things that are left up to chance. In this case, we are going to look at how we could figure out the theoretical probability of flipping a heads on a coin and rolling an even number on a die if one event was doing both of those things and seeing which pairs came up. Remember that theoretical probability is just mathematically what should happen, and we write it as the number of ways to get the desired outcome over the total number of possible outcomes. So we are going to use what is called a tree diagram. To help us organize what these possible outcomes are. So if we think when we roll a dice, there are some options. We might roll a 1, a 2, 3, 4, 5, or 6. We're just thinking about a standard dice. So these 6 numbers here are going to represent the possible outcomes when you roll a die. Now, if I roll a 1, with that, if I'm doing a coin toss, I could also flip a heads or a tails. If I rolled a 2, I could get a heads or a tails. A 3, a heads or a tails. A 4, heads or tails. 5, heads or tails. 6, heads or tails. So basically what I've done here is I'll highlight it in yellow, let's say. So yellow for the dice. These are all my possible outcomes if I roll a dice. Okay? Then you'll notice that I made branches off of each dice roll outcome. And I've put, let's say in green here, my possible outcomes if I roll, or if I flip a coin, heads or tails, heads or tails. So here at the end of our branches of our tree diagram, we can count up how many possible outcomes we have. We have one possible outcome, 2 possible outcomes, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I'm starting to write theoretical probability, on the bottom of my fraction, I'm going to have 12. There are 12 possible combinations when I roll a dice and flip a coin, which makes sense because I have 6 options on my die, and then I have 2 options, my heads or my tails. So in total, 6 times 2 is 12. So it's a kind of a quick way to figure out the total number of possible outcomes as well. Then we need to look for our desired outcomes. So I'm going to highlight that in red. So desired outcomes in this case are flipping heads and rolling an even number. So my even number on the die are 2, 4, and 6. With that, I could roll a 2 and a heads. That would be a desired outcome. 4 and heads would be a desired outcome. 6 and heads would be a desired outcome. So in total, there are 3 possible ways that I could roll the die and get an even number, and then flip the coin and it landing on heads. So my theoretical probability is 3 out of 12. So again, I can simplify this and I can write it in different ways. So in this case, 3/12, it simplifies if I divide that by 3, this by 3, to 1/4, which we know is equivalent to 0.25 or 25%. So you can use theoretical probability to make predictions. If we were going to actually go through and do this experiment, let's say we did this 10 times. I rolled the die 10 times and I flipped the coin 10 times and I kept track of everything in a table. And then I could look and see that about a quarter of the times, or 25% of the time, we should get this outcome. So if we did it 100 times, we would expect this to show up about 25 times. If we did it 50 times, we would expect it like 12 or 13 times. So hopefully this helps remind you about how you can organize theoretical probability using a tree diagram.